Hi everyone. In this video, I'll be talking about currently the idea of permutations, and in the upcoming video, it will be about combinations. So in the previous video, we already talked about the idea of factorial notations and arrangements, and then arrangements is particularly very related to the permutations. Okay, so there will be some similarities that you will see between the idea or the context of arrangements, like before you saw that the idea, let's say you want to take a group picture of 4 people, and then the way you arrange them, it will be 4 factorial. Or if it's like you have 7 different books and then you want to arrange them on a shelf, it will be 7 factorial. But then that is not always the case of arrangements, right? Sometimes you have 7 books, right? But the capacity, let's say it's only for 5 books. Okay, you only have capacity of 5 books. So in such a case, like how many ways can you arrange the books that you have on the shelf, right? So it's a different case. So in terms of the concept, so as an introduction, you may want to see here that the idea of permutations is still about finding the number of ways of arranging objects. Be mindful of the keyword. It's all about arranging. It means you take something and then you want to arrange it. That's why, because of that, there is no repetition also. And then the very important part that will later distinguish between permutations and combinations is that this one. Here, the case that the order is really important. The order is considered matters. So I'll show you what it means later on. So in terms of the formula can be written like this: NPR, or in some textbook they write it as PNR, or they write it like NPR. It doesn't matter which one. But then it means that n factorial over n minus r factorial. So for example, if you have, let's say, 10p2, that means 10 factorial over 10 minus 2 factorial, or that's simply 10 factorial over 8 factorial. Then you can solve it by using calculator or by calculation. Simple like this, cancel, cancel. So that's why you see why it matters to know this property of factorial. You can use your calculator, definitely, if it's allowed as well. Okay, so let me move on to the examples. So let's say I give you 3 examples over here. So let's take a look over them one by one. So let's say for this one, let's go with the number 1 first. So in the case of this, find the number of different ways that full books chosen, see, right? 4 books chosen from 6 books be arranged on the shelf. So you may, in some cases, you may want to arrange everything, all the 6. But if all 6, that will be 6 factorial, just generic arrangements, 720 ways. But in this case, you want to have only 4 books arranged. So if we look up with the first idea that we have last time, with the 4 spaces on the shelf, the very first one, that you still have every one. You still have all the books possible, right? So that will be 6 possibility. In the second position, it will be only 5, and then only 4, and then only 3. In the idea of arrangement, we'll go on until 2 and then 1, right? But in this case, no. So we only stop over here until 6, 5, 4, and 3. And then the same thing, we multiply all of them. So you get, it seems like it will be 6 factorial over 2 factorial, right? So you see how it is related. So let me just give you another one example. So for example, we have this one. Do not calculate that one first, by the way, just for you to know, for you to see later. How many different 5 digits can be formed using the digits 1, 2, 3, 4, 5 until 7? So the number of digits that you have available, there are 9 of them, right? But you cannot use all of them, so you need 5-digit numbers. So the same thing, you have 5 spaces, so you'll have possibility of 9, 8, 7, 6, 5. You multiply everything, then you'll get 9 factorial over 4 factorial. So try to think of it why I put it as 9 over 4 and 6 over 2, each factorial in the 2 cases. Then you can also write this as 6 factorial. Should write using another color. 6 factorial over 6 minus 4. and this one 9 factorial over 9 minus 5 factorial, which correct. If you remember that, it means this is basically 6p4. This is basically 9p5. So if you go back to the definition or the explanation over that above, simply the number over here shows the availability of like all the objects that you have. That later you will take some to arrange, and the number 5 over here or the number 4 over here is that the number of objects to be arranged. Okay, so then you of course you can calculate it by using calculator. So last but not least, the last example over here, find how many different 4 digits numbers greater than 4,000, so I'll give you the difficult one, that can be formed using the digits 1 until 7. It means you have 7 available digits. There means that n is 7, but you cannot use all of them. You need only 4, right? The r will only be 4. However, there is another restriction here. If no restriction, it means there is no note of greater than 4,000, you will get only 7p4. That means 7 factorial. 7 minus 4 factorial. It means 7 factorial over 3 factorial. You can use calculator to calculate this, by the way. You don't have to do it one by one or manually like this. Cross out. 40 times 20, so you got 840. But because there is a restriction, right? With the restriction of greater than 4,000, this makes it more interesting. So you have to put it this way. 1, 2, 3, 4, right? You have 4 digits. To make sure that it will be more than 4,000, so you have to be very clear on the very first position, right? You have the digits. Earlier you go from 1 until 7. So it means this guy must be either 4, 5, 6, or number 7, right? Well, the numbers on the right side, the second until fourth, it's up to us. It can be any number, right? It means this part will be 4 possibilities. Then on the second position, because you already used 1 on the left one, so then now remaining 6, 5, 4, which means, in other words, if you multiply this, you can do it this way, so 24 times 20, so you got 480, or you can put it as a 4 times 6p3 also. That will also be fine. Either way, method will be fine. So I end the video here, so you may want to try to think about it again. Take a look over the example once again. Pause the video, make sense of it, like why it works that way. Then you may want to try other examples if you wish. Okay, so that's it. Thank you. All the best.